Good afternoon. Today I'd like to discuss first a problem that I encountered doing some programming on Windows in assembly language. We haven't been using Windows before, but it's not too hard to use. So we'll do that first. And I need to start the EB program on Windows and then switch my Google Plus screen sharing to the EB. All right, this program is relatively short, and I thought that I would take advantage of the BSS segment. And as you can see, there are 1 billion bytes in this data array. And the program does a little shuffling here that I won't bother with, but by the time it gets down to line 28, it's ready to read from either a file that's named on the command line or standard in, and I'll use the file junk, which is 1 million bytes in size. So I'll click on the EB icon and it runs the program. So we're ready to call the read function, and looking at the registers below, we can see that we're asking to read, it's in register 8, which I will change to decimal format. I'm trying to read 10 million bytes. It's more than the file has, but let's see what happens. Click the wrong button. All right, doing one step, we can see that register REX has all else. That's not 100,000 bytes, so we are not seeing success. All right, so what is going on? Well, let's try changing things a little bit. How about 10 bytes? Run the program again. I want to tell it to read 10 bytes, and it dutifully gives us 10 as a value in RAX. So I can read 10 bytes successfully. Maybe I'm asking to read too many and it's just crazy. Let's see again. Try it with 100 bytes. Well, that's curious. Now we're getting 99. Why 99 and not 100? Reading from a disk file, you seldom have a problem of the reads ending before they're completed. So let's give it 1,000. And step forward one more instruction, 982. So this succeeded. 10, 100, 1,000, let's try 10,000. All right, stepping one statement, making the call, 9,844. We can read 10,000 bytes. Let's read 100,000 bytes. -1. Well, that's curious. Why is it showing us a -1? It's failing to read. That's another value. It worked for 10,000. Let's try 20,000. -1. So somehow, when I try to read more than 10,000, I don't know exactly what the number is, things fail. and I get fewer bytes than I asked for. Well, it was a little difficult to find this, but one clue we can get from running the debugger. Well, we're a little slow getting the program started up. All right, now I'm going to switch to a terminal window. And do GDB with the program, which was chksum.exe. GDB doesn't work very well under Windows. If I tell it that I want to list lines 1 through 10, it's showing me a different file from my assembly language code. So, and it doesn't really understand the line numbers of the file, but I can break it main. It understands at least that much. So now we've told it to break at main, and I'm going to do the examine command and tell it to examine, let's see, 1,000 bytes in hexadecimal, starting with the address of that data array that's in the BSS segment. What's all that stuff? Let's try it again. Look at the start of this. We'll go for 10 bytes. Now, 10 bytes, you can see that the labeling says data, data plus 8. Let's try 100 bytes. Saying that there's something right after data, after maybe data plus 80 or so, that's called new mode. What is new mode, and why isn't it data continuing on? Well, the answer took a while for me to figure out, but if you do the size command, it tells you the information that gives the big clue. Oh, the BSS segment for this program is 5,712 bytes. And if we then do obj dump minus h for the object file, there it's telling us in that object file the size of the BSS segment is 46 hexadecimal. All right. Now I'm going to do a little bit more. Let's see. EB operates using some parameters that are set in .ebe.ini. And I've changed my file to be expert equals true. I don't like the idea of using tricks like expert, but I had a reason for it. In any case, I can go into the program and edit settings, but I can't change the expert value in here. I don't think I've added that to this. Make sure we see in the, now we need EB. Or not. All right, here's edit settings. So now, yeah, when I named it, I originally had it YASM dash. Then we need to switch back to, and and I had And what I'm showing the 1 point. My program, I believe I have configured EB with edit settings dialog to use the most recent version. So yes. And Peter Johnson repaired repaired YASM for me because I posted a ticket, and now it works correctly. So YASM now keeps track of the size of BSS properly with Windows and placed it in the object file, which made it into the exe file, and now it's just fine. So we can change the size of this read. That'll be big enough. And if we execute the call to the read function, now we see that we have 985,162 bytes read. Well, this is not quite correct. What is really occurring is that when you read or write a file in C in Windows, C thinks that it is doing translation from the Windows format for text files to the Linux or Unix format. And the difference is that each line with Unix is ended with a new line character, and each line with Windows is ended with a carriage return character and then a new line. And we want the carriage returns and the new lines. It's interesting though, when it does this read, it converts, it reads the entirety of the file, which is 1 million bytes. Then it gets rid of the carriage return characters from each line, and you end up with that many. You can change it by ORing in your, binary. That's bonary. The spelling here doesn't really matter because that's in a comment. Here is going to be, I believe, I can't remember. I think that was the value. We'll see if it works. To determine the value, I wrote a C program that printed out these values. Now you can see that RAX is 1 million, so it's reading the file correctly. You have to tell it that you want to read it in binary mode, and then you have to have the assembler giving the right size for the BSS segment. Little glitches. It was a bit unexpected to have an actual bug in the assembler. Generally, compilers and assemblers do not have bugs, but I make errors. All right, so now I'm going to crank up EB under Linux and get back to the normal stuff. All right. Don't know if I was visible then or not, but now we'll crank up EB and we have no code in it. And my goal for today was to experiment with control flow, if statements, switch statements, and probably loops. These things over here on the right in this template toolbar, these icons will give you little bits of code. This one will give us a main program. It will if I have a file name that ends in .asm. So I'm going to do a save as, and we'll call this ifs.asm. Now, having ASM as a name, it should be capable of doing that. All right, so now we have a template main program. And you can see it has set up a stack frame and then leave and return. And this also gives us some details about how to deal with parameters to the function. So how about if we make this program check to see if we have any command line parameters. The first thing we want to do then is to do an if. And I clicked on the if icon up here, and we have the general structure for an if. Whatever you want to do, this is a comment. If RAX is greater than 5, use CMP RAX, 5. And then my suggestion is do jump not greater than the reverse of this operator to give you something that resembles as closely as it can the test that you wanted to perform. Then you do what you want to do with it. So let's try, how about instead of RAX, we want the first parameter, which the first parameter to main would be RDI. How about then we do if RDI is equal to 1. If RDI is equal to 1, that means we've got just the program name. So we have here the comparison is compare RDI with 1 and jump on not greater than, well, we need to, how about jump not equal to end if. And then we can do what we want. And I think I would like to print argv0. To do that, we'll scroll upwards. We need to tell it that we want to use printf. All right, so do extern printf, and then we need to deal with the command line parameters, which is an array. It's in the second parameter, RSI. RSI then has the address of an element of that array. So let's do this. We want to move the first item of that array, which will be RSI, like that. And we want to print that. And we want to print it as a second parameter of a printf. So we need a first parameter. May as well put the first one first. And we'll do a load effective address RDI. The first parameter for printf is going to be a format string. And the format string needs to be declared in the data segment for convenience. You can have it in the code segment, but you need to make sure you don't accidentally execute the format statement. So segment dot data, and then format DB data bytes, and it doesn't matter if you use single quotes or double quotes. All right, argv bracket 0, the first item, and I'll use equals here, and then %s is the the printf pattern for printing a string, and we need to put a new line character in it. So you can't use \n, excuse me. So we need 0x0a, and we need a 0 byte at the end of the array, which we can just do a 0 that way. After defining that bit of data, we got to set the segment back to the text segment. The last thing to do is to set to set the number of let me get back to what I was doing here. Oh, set the number of floating point parameters to printf, which is going to be 0, which we put that in RAX. So we do XOR, exclusive OR, EX, comma EX, and then we can call printf. And I should have everything I need here. I've got the test, jump not equal to, since the test was equals, jump to end if, and if I did that right, it should work. And let's tell it to view the terminal, and I'm going to move the terminal down to the bottom on top of these other things. So now we can see that, and I will put a breakpoint on line 12, tell it to run the program. Let's see what happens. All right, looking at the registers, that RDI says 1. That's what we're trying to compare against. And RSI is an address that is on the stack. Go forward, and we can see that the 0 flag is set, and 0 flag means that they were equal. The subtraction, which is RDI minus 1, gave a 0 that wasn't saved. Compare just subtracts and throws away the answer, keeps the status. So we go forward, load effective address of that format. You can see that address is in the data segment. All right, now we can see all the registers. And we do XOR, and we've got RSI and RDI done. Call printf, and let's see if it works. So it's saying that the 0 Cypher ASM ifs, and that is the program name, and it's Linux, so the name is IFS and not ifs.exe, which would be under Windows. All right, so that worked fine. We got an if statement. Let's look briefly at an if with an else. And which is some code. To do, it's got 2 little red boxes, and here a little bit 2 things to jump to. So we have a comparison at the start, and then we jump past the first part of the if, the then, whatever you're going to do. And so this level and what you get the end of the if. We have this strange symbol which has 4 little for a switch statement. Switch on says your microphone is not working. It doesn't seem to be. I see lights when I speak. I think it really is working. If it's not working, this is going to be boring. All right. I'm going to assume it's working. I can't really tell. If somebody can send me a chat message or something, perhaps I can then discover whether it's working. All right, going ahead. Back to the switch statement, switch on I for convenience. I to a register, and then you'll have a sequence of tests. So for case 1, compare that register REX in this case with 1, and if it's not equal, go around. Don't do the work for case 1. And case 2 is right here. So if your value were a 1, you would do the work that you wanted to do when I equals 1, and then to implement the break, you need to jump to the statement that ends. And if you fail on this test, in other words, if you do the jump not equal, or I not equal to 1, then we have case 2, compare REX with 2, and jump equal to case 3. Same kind of pattern here. Case 2, you've got some work you want to do, then a jump to switch in. And then case 3, well, in this case, it's really going to be the default. And for the default, there's no test. You do whatever you're going to do, and then you fall through to switch in. All right. I believe I will wipe out the switch code and put in a loop. All right. This loop is a for loop, and we'll look at it put in a while loop. All right. So for a for loop, you have int I equals 0, so you have to have an initialization for the for loop. So here's an initialization, and then I've got a label for top of 4. Then there's a comparison at the beginning of each loop, compare EAX versus 10, and if it's not less than, jump out. Obviously, you could change this jump greater equal JGE, but using NL makes it match the appearance of I less than 10. So you do whatever you're going to do in the loop, and then increment the value for the loop counter, and then jump to the top of the for loop. You can compress this a little bit by recoding it using a do while loop. I don't want to put in a for loop right now. All right. The next one is a while loop. And what I want to do is print these arguments for the whole collection of arguments. If I put in a while loop, there's a test at the start, and I may as well put it in there. This will do. I could put it in with a do while loop. All right. So while what? If we want to print all of the parameters to the program, let's say we want to print A, B, and C as additional things, then we have a little adventure. What do we use? We can make it count, or we can make it use an address. Let's make it count. And the value that we want to count with is RDI. And if RDI is, oh, this is interesting. If we're going to count with RDI, we have another small issue. We need to have something to count up to make it equal. So I'll just say XOR how about ECX? So ECX will be 0, and then the comparison would be like while EDI, so ECX is less than EDI. Does that sound right? When we have 1 for RDI, we're going to have 1 parameter, and we want to print something when ECX. Then when it becomes 1, we want to quit. So I think 1 sounds, or less than sounds correct. So we'll do ECX versus EDI, and it's got less than, jump not while, or jump not less than to end while. And I'm not going to repair the comments. I think I will just leave them there. All right, so what do we want to do in this loop? I think we want to do roughly the same thing as what I did earlier, except we want to print a general pattern instead of printing just argv0. I don't need that, but I might like to do this part, so I'll drag this down, put it into the loop. Oh, need to get rid of it. Control X. Control V. So now we have some stuff to do in the loop. All right, instead of printing argv0 equals something, how about %d? So now we want to print 2 things, and the first thing we want to print is the first parameter is printf, and then the second thing to print is going to be that number, which is the value that's in ECX, but it's got to be into ESI. And then the third parameter is, I think we have that printed up here, RDX. So going back, then we want to move our address of the thing to print, and we want to change it each time through the loop. So we can do plus, and the register RCX would work pretty well, but that's going to be changing by multiply this times 8. And this will add 8 for each time RCX changes by 1. and I should have it correct. Except one more thing, we need to increment RCX, and then we've got a little bit more work to do, probably ECX will be good enough. We need to have these registers available for the next time we're in here. When we call these parameters, so let's run it knowing that it's not going to work very well. Let's clear the output, and let's put in a breakpoint on line 26, run the program, and let's see if we get it to print argv0. Ooh. Not good. This feels like a bug in EEBEE for dealing with my code. I don't think I've changed anything so where it shouldn't work. We don't want to move that into RDI. It should be RDX. That shouldn't make it completely screw up. Oh, it thinks it's on the same line. All right, I'm going to get rid of the breakpoint and see what happens. Not cool. Going to start this program over and see if it will behave. Going back to line 26, let's see what happens when we hit that point. That's what I was afraid of. It's continuing to get stuck on that line. I'm not sure what's happened here. I would expect this sort of behavior possibly with Windows, because with Windows I have to interpret line numbers and stuff. So let's give up on this and go straight to GDB and see if we can make it cooperate a little bit. GDB ifs and break at main. I think break at 26 would be better. Let's just run it. Run A, B, C. We get 4 parameters all together. And next, place hitting enter, it'll do that. Segmentation violation. Oh, I needed to report that, didn't I? So yes. The program has died trying addressing with RSI plus RCX. RSI is a 0. Oh, yeah. So we moved a 0 into there earlier. So we got a little conflict. We need to deal with these registers immediately. I'll get back into EEBEE and take a note that I need to handle segmentation violations properly. All right, so a little confusion here. we need to use a move into RSI from this line to that line. So we need to save these things later anyway. So let's try creating some space for registers. We could put them into the stack, but it's probably easier to save registers in something in the data segment. So segment, data, and we want to save probably RCX, which we're using. And save RDI, the first parameter domain, which we're going to be using. And save RSI, the second parameter. That's QD, not too cool. DQ 0. So now we got place to save them. If we go down here, before we call printf, we need to save them, but before we move a value into ESI, we need to use the value. So let's try doing a reversal of these lines. So now we've got a chance. But before I do, to save these registers. So we move into save RCX, register RCX, and then move into save RDI, register RDI, and then another move, save RSI. All right, so now they'll be ready when we get around to making the function call, but we'll need to restore them. So we'll need to move, and we'll get back RCX from save RCX, and we'll get back RDI. Well, that's RSI. Let's try them in the order I said. RDI, save RDI, and then move RSI, save RSI. Now let's see how it works. No death, call printf equals IFS. Then we restore the values of those registers, increment ECX, compare it with 10. Oh, well, that's not cool. So I did okay, but I forgot to change my condition for the loop. My loop is going to be while ECX is less than EDI. Why do I have that test down there? I've got a test before the loop, and then rather than have the test at the top of the loop. So you could have the test at the top of the loop. When you go back up there, you go back and test again. But rather than jump to the top of the loop and then test again, my plan was to compare them down here. And I think we had ECX, and I've forgotten which one it was, EDI. And and jump less than. Yeah, ECX and EDI, top test says jump not less than, the bottom test says jump less than. So let's see if this works. Oh, I don't have my parameters up here, A, B, and C. All right, so we print that stuff. Let's see what we got for the registers. When we restore them, RCX definitely was changed. And let's see, RDI was changed. RSI, that was changed. So all of them were changed. Increment RCX is now 1. Compare. And you'll notice down here we've got carry flag. I've forgotten the A flag. And the sign flag. I think this is going to mean, sign flag means you got a negative number, so less than should be true. Yes, we go back up to the top of the loop and we save those registers and get ready, and let's see if we printed the right thing. Oh, not good. Is RCX still 0? Oh, there, I'm looking at the wrong line. It is good. argv1 equals A. So let's just tell it to continue. All right, finally it did the continue. And we see ABC. I'll take off our breakpoint. And it doesn't matter what we put here. We can put any string that we wish. I'll tell it clear the output and run the program. So we print argv0 is the ifs program, and argv1 is hello, argv2 is there. We had a little glitch in the presentation today. My network got screwed up. I think this is probably enough code for one day. The while loop, as the way I did it, I put a test before the while loop for efficiency's sake to dodge the loop, because that's the test before it does it the first time. And then I put a test down at the bottom. The test at the bottom is like a do while loop, which I will I'll put in the little template code for that. That is, let's see, this is a test at the bottom, I guess. Yeah. And in C, that's, or C++, do, and then a test at the bottom while, so it does it once, no matter what. And then it does whatever it has to do and does the test. All right. Oh, it's showing me compress. I don't know if that's what I look like on the internet or not. I'm going to briefly switch cameras. Yeah, that's compressed also. I don't know why it switched back, but it did. I think I'm being shown compressed. Whatever. I don't need to do anything more. I thought I'd get back to here and see if someone had posted some sort of questions. I don't see any. Not in chat. Question and answers. No questions. 2 viewers. I lost my picture. Camera's dead. Well, that'll conclude this for today. See you next time.